Here we have a paper 2 challenging question I found on Revision Village. It's not challenging in the sense that it has a lot of calculations. It actually doesn't, but it's challenging that you need to make good observations with what's happening inside or on the graph, and how you take advantage of that to help you crack a few problems, and how you connect the information given between problems to help you solve like a new problem coming afterwards. So now we have a function for an ellipse, and the problem tells us that it's centered on the origin O, and then it has a rotation symmetry of 2, order 2. It's okay if you don't really know what that means. It's not super helpful for this problem. So let's jump into part A. Show that dy over dx equals to x minus y over x minus 4y. So now we don't use our calculator. We just do algebraic steps to show. And here, since x and y are both on like one side, so we need to do implicit differentiation. So by doing so, I have like 2x for the first term and minus 2. So what I do is that I write minus 2 and then like parentheses and differentiate what's inside. Now it's product rule, right? So I differentiated x first, so we have y left, and then differentiated y next. Now we have to differentiate this. It's product rule, right? Because we have y to the 2, while y is a function of x. So it is 8y times dy over dx, right? And then remember, the derivative of a constant 8 is just 0. So you have this. And let's pull out dy over dx, move the other things to one side, simplify, and just make sure the final answer looks like what's given here. Not very hard. So now we have part B. Show that the equation of the horizontal lines which are tangent to the ellipse are y equals plus or minus this value. So remember, horizontal lines, they must be like this, right? So the function for that is just y equals to like a constant, and they're tangent to the ellipse. So it's asking for so at these 2 points, right? These 2 points, 1, 2, we have this horizontal tangent. So it's asking for this. Show that like their functions is this. So we already have this, and we know that the horizontal tangent is when dy over dx equals 0. Like the slope of the tangent is 0. So that means x minus y must be 0. So x equals y, right? And remember, we have our original formula, so we can substitute x equals to y back in there and find the y values. Or you can find the x value. Like both ways are fine because they're equal. So you just find them and then make sure that they equal to plus or minus this thing. And now use a similar method to find the equation of the vertical lines which are tangent to ellipse. So on this ellipse, the only 2 places that the tangent can be vertical is here and there, right? So now remember, a vertical tangent is when this thing becomes something divided by infinity, right? So it becomes like extremely steep. So we just said x minus 4y becomes like as 0, and then we have x equals to 4y. And remember, for a vertical line, the function is always x equals to some kind of constant. So we want to find the x values, so we don't we don't really need to find the y value first and then find the x value. We just find the x value directly. That means we should substitute y with something of x. So y equals to x over 4, right? And then we put everything back into the original equation and then combine a little bit. And since this is paper 2, you can use the GDC for this part. X is approximately plus or minus 3.27 for the equation of the vertical lines. So now we have 3 more questions, C, D, E. So now it's asking for the top part of the ellipse. So it's from here to there, the solid line. It might be a little hard to see, but it just means from here to there, like the line occurring here. And it wants you to show that this part that I just traced can be defined by the following function. So at first you might be a little confused of like, how does it want you to show it? Like what is it asking for? So observe that there's only x within. So that means we managed to isolate y. So this is like y equals to something, 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 right? All we need to do is that isolate y from the original function and then make sure that y equals to something that looks like this. So that's what it means. So I just copy down the original function, and I first move the terms without y to one side, and then I pull out the factor of 4 from the side with y, and then so here's the important part, like how do you actually isolate y, right? So you can do something called complete the square. I'm sure you're familiar with it, so complete the square. How? You see that you have y squared minus something, right? So this is like a squared minus 2ab already. Then you should have b squared. So you set this to minus 2ab, and this is just a squared. And then for b squared, you would just have something like x squared over 16. And since you added something additionally, you got to subtract it outside. So I just subtracted by the same value. And now you just move this subtraction to the other side. So you have 4 times this like a minus b squared thing, and then this thing on the other side, and then you can divide both sides by 4, and you notice that this is starting to look like what's given here. So like when you're doing show questions, my suggestion is that you always check whether you are approaching some kind of expression in here. So you want to check whether you are on track of approaching what they want you to show, right? So now we have like this thing inside the square root already, right? And now we just take the square root and then rewrite this as a fraction, like 32 minus 3x squared over 16. And then let's just move the final thing, x over 4, to the right side. So we'll end up with this f of x equaling to the thing in the question. So that's the entire process. And part D is that says that the region A above the x-axis, so this region is enclosed by the ellipse, and it wants us to find the area of region A, right? So you can't really use the original formula to like write an integral because it's like has x and y both in there, right? So you only want a formula with like a function formula with x inside, so you need to take advantage of this one. However, you notice that this is for the curve one, it's from here to there, but for region A this time it starts from here and it ends right here, right? But if you observe a little more carefully, it's actually, we can make it look like what's given in part C. So we can just move this part of the curve down here so that, hold on. We move it down here so that we now have this curve. And then the area is not anything diminished because we just managed to move like this extra part down here. So like we're just moving things, we're not decreasing things, right? So now we can just write an integral of, since we have moved a part of the curve from here, let's call A and let's call this B, integral from A to B, and then of f of x dx. So that's how we can solve it, and using our calculator. So we already have A and B, if you remember, because we already solved for the vertical tangent lines. So you have the x values, which is 3.27 and negative 3.27. They will be the indefinite integral, like the kind of like the domain in there. And then you copy down f of x dx and then put it into your calculator. You'll get this value as the area of the region. So like the little tricky part is that you have to make the observation and like use something in a previous question to help you solve for it. The observation is that you can like make the curve look like the one in the previous question and solve it using what's in the previous question. So the last part is that a company wants to make a logo by inscribing the ellipse inside a rectangle, and we have this shaded region B, and we want to find the area of B. So the area of B is just the area of the rectangle minus the ellipse. The area of the rectangle is kind of straightforward, I would say, because, so remember we have like the axis like this, right? That is what we got, like x is negative 3.27, and here it's like 3.27. So we already have the length as like 2 times 3 times 27, right? And then the height, remember the height is the like y equals to the horizontal tangent lines, right? So that's just y equals to plus or minus this thing. So the height, like the, or you can call it the width, is just 2 times this. So this is the height, and we already have the length, right? So we already have the area of the rectangle from the points we got previously, and the area of this ellipse, remember, is just twice of what we got in part D, because in part D we found the area from here to there, so that's like half of the ellipse. So we just multiply that by 2, right? So it's just 7.25 times 2, right? So it's just this thing subtracted by this thing. Just make sure you like write down the correct values. Yeah. And then you will get 6.82 in the end. Thank you for watching.